For decades, physicists have been on this quest for a theory of everything, some single, elegant idea that can describe the entire universe. But honestly, they've kind of hit a wall. So today, we're going to look at a radical new proposal that doesn't just try to fix the old theories, but rebuilds physics right from the foundations. It's called quantum geometry dynamics, or QGD for short.
To really get what this theory is about, let's start with a wild question. We experience reality as, smooth and continuous. But what if, at the most fundamental level you can possibly imagine, that's all just an illusion? What if space itself is actually made of tiny, indivisible units, almost like the pixels on a super high-res screen? And that one idea, that's the key that unlocks this whole thing.
Okay, but why? Why do we need such a crazy idea in the first place? Well, it's because modern physics has a huge problem. It's built on two amazing pillars that work perfectly by themselves. But when you try to get them to work together, the whole thing just falls apart.
On one hand, you've got Einstein's general relativity. It's beautiful, and it flawlessly describes the universe on the grandest scales. Planets, stars, galaxies, all moving through a smooth, continuous spacetime. But on the other hand, you have quantum mechanics, the undisputed champion of the tiny, subatomic world. And its reality is lumpy, weird, and quantized. The problem is, their core assumptions are total opposites. You can't have a smooth reality and a lumpy reality at the same time. They're like oil and water.
So QGD's approach is to just stop. Stop trying to jam these two puzzle pieces together. Instead, it asks a different question. What if we're starting from the wrong place entirely? What if we could build a whole new foundation for physics using what's called an axiomatic approach, starting with just a couple of rock-solid, simple truths that we can't possibly break down any further?
This actually follows a principle from the main man himself, Albert Einstein. He was convinced that the ultimate theory of everything shouldn't be complicated, it should be incredibly simple at its core. QGD really runs with this, saying that when you get down to the very bottom of it all, reality isn't more complex, it's way simpler.
So, if we're going to build from the ground up, we have to ask a really simple question. Let's forget black holes and quarks for just a second. What do they, and a baseball, and you, and everything else in the universe actually have in common? Well, according to QGD, the answer is just two things. They all involve space, and they all involve matter. That's pretty much it.
And from that one simple observation, QGD builds everything on just two core axioms. These are the absolute ground rules. Axiom 1, space isn't an empty void. It's physically made of tiny, discrete units, which the theory calls preons minus. Axiom 2, all matter, every single bit of stuff, is made from just one type of particle that's always in motion, called a preon plus. And that's the whole recipe. The entire universe is just different combinations of these two ingredients.
All right, so let's just grab that first axiom and see what happens when we pull on that thread, because the idea that space is made of little, indivisible bits has some truly bizarre and frankly counterintuitive consequences for how we think about something as basic as distance.
Now, the key thing to get here is that these preon minuses don't exist in space. They are space. They are the fundamental locations. And what's between them? Not more space, but a repulsive force that holds them all apart. Think of it like a universe-sized crystal, where each point is a tiny marble pushing all the others away, creating a fixed grid for reality.
And this is where it gets really wild. In this pixelated quantum geometrical space, everything you learn in high school geometry pretty much goes out the window. At this super fundamental scale, the shortest distance between 2 points is absolutely not a straight line.
Now, in our smooth, everyday world, we all know Pythagoras' theorem, right? The hypotenuse, that diagonal line, is always the shortcut. But in this weird, pixelated space, distance is measured by counting the hops from one unit to the next. So as you can see here, moving along side A is 5 hops, and side B is another 5 hops, for a total of 10. But trying to cut across the diagonal, that actually takes 12 hops. It's the longer route. Crazy, right? So you might be asking, why don't I notice this when I'm walking to the fridge? It's a matter of scale. At our level, we're moving across such an astronomical number of these tiny units that all that weirdness just averages out, and the smooth, normal reality we know and love emerges. It's exactly like the pixels on your 4K TV. From the couch, the picture looks perfectly smooth, but get right up to the screen and you'll see the individual dots.
Okay, so that's space. Now let's talk about the stuff in space. This is the second axiom, and it redefines what matter, mass, and even energy really are, all with that same push for radical simplicity.
Say hello to the Preon Plus. According to QGD, this is it, the one and only fundamental particle of matter. Everything that has substance, an electron, a planet, you, is just a big collection of these guys. And here's the kicker. They never ever stop moving. They are strictly kinetic, which is a fancy way of saying they are constantly leaping from one point of space to the next.
So then, what is mass? In QGD, it's not some deep, mysterious property connected to gravity or inertia. It's just a number. It's literally just counting how many of these little Preon Plus particles an object has. An object with more mass, it just has more stuff in it. Simple as that.
And what about energy? Well, in QGD, energy isn't some abstract field. It's the sum total of all the motion of all the little preons plus inside something. The theory says each one has a fundamental, constant amount of momentum. Let's just call that C for now. So, the total energy E is just the number of particles, which is the mass, m, times that fundamental momentum, C. And look at that, you get E equals mc, derived right from the ground up.
Right, so this brings us to momentum. If an object is sitting perfectly still, it doesn't mean its guts aren't buzzing with activity. They absolutely are. It just means all those preons plus are zipping around in random directions, so all their individual momentums cancel each other out. The overall motion of an object is just the grand total of where all its tiny parts are headed.
Okay, so this is where it all comes together. These new definitions for space and matter and momentum, they aren't just fancy ideas. They give us a whole new mechanism for how things actually interact, a new way of understanding how things move.
Think about two billiard balls hitting each other. Classical physics is awesome at predicting what's going to happen. It can tell you the angles, the speeds, everything. But it's kind of silent on how that momentum actually gets from one ball to the other. QGD wants to pop the hood and show us the gears turning behind the scenes.
So here's how a collision works in QGD. Two objects get close, but remember, they can't be in the same spot at the same time. So at the very instant of impact, they don't push each other in the way we think. Instead, it's more like a trade, a momentum swap. Each object shoots out photons that carry its momentum, and the other object absorbs them. It's not a collision, it's an exchange.
And this swap isn't a free-for-all. It's got some really strict rules. Two objects can't be in the same place. Momentum is always conserved. But this third one, this is the real game changer. Momentum can only be exchanged in specific whole number chunks. You can't just add a little bit of momentum. It has to be exactly 1 unit, or 2 units, or 3. No fractions allowed.
And this rule, which sounds kind of abstract, has massive implications. It beautifully explains one of the weirdest things in quantum mechanics, why an electron buzzing around an atom can only absorb photons with very specific energy levels. Why? Because, according to QGD, that electron can only change its momentum by those exact integer amounts. If an incoming photon doesn't have the perfect amount of momentum to make one of those allowed jumps, the electron just can't take it. It's the wrong size.
So let's just step back for a second. What's the big picture here? QGD is proposing an entire reality, from the tiniest particles to the largest galaxies, that's built from just two incredibly simple rules. Space comes in chunks, and matter is just one type of particle that's always moving. From that foundation, everything else, mass, energy, motion, even the weird rules of quantum mechanics, just sort of emerges.
Now look, QGD is still a new idea on the block, and it's got a long road ahead to prove itself. But it leaves us with this incredible, mind-bending question to chew on. If our most basic, fundamental assumption about reality, that it's smooth and continuous, is actually wrong, what other obvious truths are just illusions, waiting to be shattered by an even simpler idea?